SciComm team, and I am here today with Frances from the education team, and we're going to go over some really cool activities to do at home. Things that you can use around your house to create some really interesting things like, what are we doing today, Frances?
Today, we're looking at being robotic engineers in space. We're going to make and design robot arms and then test them and see how well they work.
Make a robot arm in your own.
Make a robot arm.
Yeah, really cool. So, all right, so what do we do?
Okay, so this robot arm activity, we're looking at one of our Space Week activities that you can find on spaceweek.ie, and it is engineering in space, all about astronauts aboard the International Space Station. And this is part of the Mission X project. You can zip over to ESERO.ie, find their project page, and that will take you on to Mission X if you want to take part in the full project. Now, throughout this, we're going to be taking an inquiry approach. So asking questions, engaging interest, carrying out an investigation, and then figuring out other next steps we could take. So our first question to really get us engaged and get us interested is a trigger. What is cool about this? So look at that picture, Danielle. What do you see?
Well, the first thing right away is the astronaut. And
yes. So she's called Samantha Cristoforetti. She's a European astronaut. And this photo was taken when she was on the space station, which she was between the end of 2014 and the beginning part of 2015. So 199 days in space.
Oh my gosh, that's amazing.
Just so much fun. Where is she?
First thing I noticed was her hair floating, and you could just tell that she's in space. And it looks like she's doing photographs. Is that what it is? Photography?
Yeah, so she's got the camera in her hand, and she's looking out the window of the cupola. So that's really cool. The window area aboard the International Space Station. So she's looking out, and the Earth is below. So just to one side of the screen, you can see the Earth. Yeah. But in the screen, that's the end of the robot arm, the Canada arm, that is the workhorse of the space station. It's how the space station was built. So there's a robot arm that is controlled by the astronauts, and it moves everything around.
How cool is that?
Oh, so cool. Okay, so we've got the idea that these robot arms exist, used by astronauts to control and move things when your own arms couldn't reach. Like you can't reach outside the space station.
Right.
Okay, even if on a spacewalk, you can't grab a big thing and move it around, so you make a robot arm to help you. So we're going to make our own robot arms. So
just like the one from the space station.
Yeah, this is part of engagement. Now, this is a simpler robot arm than the space station. Okay. But it still has the idea that we're going to be at one end of it controlling it, and it's going to move and adjust and move something at the other end. Now, there's a how-to sheet in our spaceweek.ie resource, and it shows pretty straightforward that you're going to use lolly sticks.
Okay.
Okay, so I got a couple of lolly sticks here. I think you've got some lolly sticks as well.
I do. Mine look a little different than yours.
We're going to need to join these lolly sticks together. Now, two will get joined in the middle, and obviously my lolly sticks can't join because my lolly sticks are completely solid. But if we punch a hole in them, then we'll have a hole that we can use to attach them together. And the brass fasteners, the kind of split pin fasteners, are a great thing to use. But you may find at the end of a twist tie, if you have them, if you might have some plastic bags that come with twist ties, perhaps that would work, or something else that you can figure out. The idea, though, is you're going to join them, and they're free to move over each other, because we want to be able to adjust the length of our robot arm and be able to pick things up with our robot arm. So, hole punching time.
Okay.
Now, in the best style, we've already done quite a bit of the hole punching to have it already done.
Yeah.
If you find that the lolly sticks are a bit tricky to get a hole punch through, do you think something else would work? Our suggestion is cardboard strips. So you can try and find out which kind of works the best for you. So how are you getting on making yours, Danielle?
So I've got some lollies that already have pre-holes punched in them already, pre-hole punched. So I did the X's like you said.
Okay, yeah. So
I'm gonna put the fasteners through. So I've got 2 X's on top of each other.
okay. And then you're going to attach the 2 X's to each other at the edges.
So put the little fasteners through.
Now, you may need to decide, you know, does the one that's the top of the X be the top of the next X, or does it need to be underneath? Because, you know, they do have kind of a sideways width, if you look at it on the edge. So there is kind of a top one and a bottom one.
Right, yep.
And a good kind of maths puzzle for you is if there's 3 holes in each of them, how many split pins do you need?
So to figure out your supplies in advance.
Yeah, do you need 3 for every single one? Because 2 go into the same split pin, is it a different way to work it out? And there's a good kind of maths puzzle in that to work out how many do you actually need. Now, of course, you can look at our diagram and count it. And go, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 lolly sticks. And I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 split pins.
Oh, for the full arm, the one you have there, okay.
If you're doing the full thing. Now, we'll just make a shorter one with just kind of 2 parts of it.
Yeah, I've got 2 X's done. So this is what mine looks like now.
Oh, perfect. Now, if you have one end of the 2 that are joined to the same X and try squeeze.
Like that. Yeah, it moves pretty good.
You see that the far end opens and closes along with your hands opening and closing.
Yeah, that's really cool.
Now, you've seen how it works. And so that's the first part of our inquiry, is I wonder how it works. Now, how can we find out more about this? We've made our robot arm. How can you make it work better? So there's lots of possibilities here. And the best thing to do is to explore by using it. What happens if you make it longer? What happens if you make it shorter? Does it work if it's only 1?
Yeah.
If you put more on it, is it easier to work with a longer or a shorter arm? Do you have grippers? Do you have something on the ends of these that can help you pick things up? So if you think, okay, well, you need a little bit of friction to be able to grab with the end of these robot arms. So did you want to add something to those? And you could add, say, a bit of rubber. You could put a bit of masking tape on it, maybe with the sticky side out. There's lots of possibilities. And exploring that is finding out.
Ooh, so add another, look at that.
Oh, you've added another one. So is that as easy to control? Does the end seem to close up as well? Have you tried picking anything up?
So I have a little bit of the, you mentioned having something for the end. So this is some rubber on the end of your pencil. So put that at the end.
But you could try it with the grippers, without the grippers. Do they make a difference?
Okay, so this is definitely more difficult to get with the longer, because they have Now, what could you try pick up with this? Do you have any small little objects, like a little bit of Lego or beads? I've got a little dice here, so something small that will be picked, that you can pick up with it. Little lollipop, we'll see if we can get that. I've got a here. And, oh yeah, these are small, so let's see if we can get this. Okay. This might be a little bit tricky. Let's see. Woo. Oh, it's just, hey!
Well done. So all of this is what we call exploring. This is finding out about what's going on and getting some experience with it. Once you've explored and you have a sense of how this works, you can actually ask an investigation question. I wonder, how could we improve the design? And that's a really open question, and everybody might have their own ideas. So you'd predict your idea and try it out and explain why you think it would make it easier or harder to do.
Okay.
And that's a science inquiry that you've designed and developed all on your own. And really, it's up to you what you want to ask. Is it better to be longer?
There's a lot of possibilities. Yeah.
All sorts of possibilities. And this is what we're saying. I mean, making them is fun, but then investigating with them is really getting into, I wonder what's going on and why does it make a difference? And you're learning science by doing.
Mm-hmm.
Now, the real robot arms, here's one that's due to be launched later in 2020. So here, instead of having lots of hinges, we've got a wrist, an elbow, a little bit down the end, maybe a shoulder, a wrist, an elbow, and then there's a grabber on the end.
Yeah.
And this one hasn't even been sent to space yet. It's due to be launched at the end of the year. Yep. And when you carry out the investigation, you could change one thing, try to pick up the same materials. Because is it fair if you say, oh, it works really well on picking up my alien, because he's got all these bits sticking out of him, but it didn't work as well picking up my dice. Well, your dice can have the things sticking out of it. So you need to be thinking about a fair test that you're picking up the same each time. What are you measuring? How long it takes you to pick it up? Are you measuring how far you get it before you drop it? So consider what you measure, and does it help you answer your question?
Yeah, even like how tight you fasten the lolly sticks together. Like if it was tighter, it'd be a little sturdier, but then it might be harder to actually move it.
Yeah, again, so there's a prediction and a reason, and then you can go out and find out if that's valid and true.
Yeah.
What if you tried something else? So if you didn't have lolly sticks, could you try it with cardboard?
Yeah.
With cardboard, it's pretty easy to change the length of the cardboard. You could have long cardboard, you could have short cardboard. You could try maybe putting the holes in slightly different positions. Does that make a difference? And all of those extend the investigation.
Oh, okay. Yeah. Okay, cool. Yeah. So putting the holes like closer together or something like that, you could have, there's a lot of different options then.
Yeah.
Very
so
cool.
Have fun investigating and finding out.
Yeah, especially with being home, there's a lot of different objects around the house that you could try to experiment with and see, is this too, like I was just looking across, I have a little tray with stones in it. I'm like, would those be too heavy to do? Maybe that's something to try. So yeah, I can see a lot of different options and possibilities with this one, Frances. So
that's great.
So much for that one. That's fantastic. And for more information, make sure you check out our website at bco.ie for more resources there. And if you have any questions, of course, leave them in the comment section for us and we'll get back to you as soon as we read them. Thank you so much for joining us. We'll see you soon.